Hey guys, today we're going to do lesson 6.2, construct and interpret binomial distributions. Okay, so let's take a look at this key concept right here, a probability distribution. So in layman's terms, what this is just writing out every possible outcome of an event or combination of an event. So if you look at the definition, a probability distribution is a function that gives a probability of each possible value of a random variable. The sum of all the probabilities in a probability distribution must equal 1. Okay, so for example, here we have the probability distribution of rolling a die. Okay, so obviously x are the outcomes of rolling a dice. So a dice has sides, 6 sides, and they're all labeled 1, 2, 3, 4, 5, 6, as you can see. So x are the sides of the dice, and p of x is the probability that each one of these outcomes is going to happen. So, for example, there's a 1/6 chance that 1 will be rolled. There's a 1/6 chance that 2 will be rolled. There's a 1/6 chance that 3 will be rolled, so on and so forth. So that's just kind of the basic example of what we're going to do. And I'm not going to make this, I'm not going to fluff this up in any way. I just kind of wanted you guys to understand what a probability distribution is and how to read it. What you need to understand what P of X, what X stands for, what P of X stands for, and so on and so forth. Okay, so let's move to example 1. Construct a probability distribution. So let X be a random variable that represents the sum when 2 6-sided dice are rolled. Okay, it says make a table and a histogram showing the probability distribution for X. Okay, so let's look at this table. Okay, really this table is going to give you all the information you need to know about this particular event. So if you look at X, which in this case represents the sum, when you're rolling 2 dice, the sum can only 2 dice. If you roll 2 ones, it equals 2. Okay, how many times can you roll a 2 with 2 dice? There's only one outcome where you roll both dice and both are 1. So moving on to 3, it's the same thing. Okay, how many different combinations can I roll 2 dice and then end up adding up to get 3? Well, there's 2 different combinations. You can roll a 1 with the dice, with 1 dice. You can roll a 2 with the other dice and then flip it. So that's your 2 different outcomes for 3. Okay, and you can go all the way down through here, 5, 6, 7, 8, 9, 10, 11, 12. So those are all the possible sums at the top. These are all the possible sums at the top that you can roll with 2 dice. And the outcomes are the different combinations of the 2 dice that you can roll to equal the sum above it. And then underneath here, this is called a histogram. It's just another way of representing the data. Okay, obviously it's pretty self-explanatory. The y-axis represents the probability, which in this case is represented by a fraction, and the x-axis is the sum of the 2 dice. So you can kind of get a better visual representation of this probability distribution. Okay, so I'm only going to ask you to create a table, the histogram. I'm not going to make you draw one of those. If we were in class, we would do a little bit more with the histogram, but for the lack of not being together, we're not going to do that. Okay, so let's look at example 2, which feeds off of example 1. So example 1, we were essentially just creating we created this data to answer these questions. So A, what is the most likely sum? What is the most likely sum when rolling 2 6-sided dice? Okay, so looking back up at our table, this is pretty easy to recognize. Well, look at the outcomes. 1, 2, 3, 4, 5, 6, 5, 4, 3, 2, 1. So the most likely number to roll would be 7, because there are 6 different outcomes where you get the sum of 7. So the answer for A is just 7. I mean, that's the most likely sum when rolling 2 6-sided dice. B, what is the probability that the sum of the two dice is at least 10? Okay, so it has to be at least 10. So that means it can be 10, 11, and 12. Okay, so how we're going to write this is, remember, P of X is the probability that that outcome will happen is equal to, oh, excuse me, let me back up. If I can figure out how to do this. Oh, there we go. Okay, so P, the probability of X being greater than or equal to 10. Okay, so that's what we're looking at. We already have our probabilities listed up here above it. So the probability of 10 is 1 over 12 plus the probability of 11, which is 1 over 18, plus the probability of rolling a 12 is 1 over 36. So we add all those up. Remember, when you add fractions, you have to have a common denominator. So we have to convert 1/12 to a denominator of 36. So we just multiply the top and the bottom by 3. So we get 3 over 36. We multiply 1 over 18 by 2, and we get 2 over 36, which leaves us with this. Now we just add 3 plus 2 is 5. Oh boy. Plus 1 is 6 over 36. Okay, so the probability of rolling a dice and getting a sum that's at least 10 is 6 over 36. Then obviously you could, I'm better at visualizing with a fraction. It's about a 17% chance that you're going to roll something greater than a 10. Okay, so in summary, that's kind of what our lesson is today. Is that okay? I know that was very brief on that explanation, but I know this is a guided practice, and you can pause this video now and try to do this by yourself, or you can watch and then do the suggested problems. Okay, so it's the same type of problem, except instead of dice, we're going to use 4 coins. Okay, so A says let X be a random variable that represents the number of heads when 4 coins are tossed. Okay, so we're focusing on the heads part of the coin. And then it says make a table showing the probability distribution for X. Okay, so you can see here, this be a little larger. Let's try that again. You can see here I've told you X in our table represents the number of heads tossed. Okay, so let's think about it. We have 4 coins. Each of those coins has 1 heads. Has a 1 head side. So we could toss the coin and we could get 0 heads. We could get 0 heads. We could get 1 head. We could get 2 heads. We could get 3 heads. We could get 4 heads. Okay, so those are kind of our possible outcomes. Okay, so those are the, I guess, the possible amount of heads you can get when flipping 4 coins. Okay, so let's work on our outcomes now. Okay, we do this by using combinations. Okay, so for this first combination, for 0, we have 4 coins, and we're going to choose 0. Okay, so we're not going to flip. When we flip these 4 coins, none of them are going to land with heads up. So you can type that in your calculator, 4 choose 0. You'll just get 1. Okay, for this one, we have 4 coins. We want to choose heads once. So there's 4 different coins, meaning that there are 4 different ways that we could just flip 1 head. The next one would be 4 choose 2. If you type that in your calculator, just like we did in the last section, you'll see that there are 4 possible outcomes. Excuse me, not 4. There are 6 different outcomes for flipping 4 coins and getting heads twice. Same thing, 4 choose 3, we're back to 4. And then 4 choose 4, we're back to 1. Okay, so how do we do the P of X, the probability of each of those outcomes happening? Okay, so we want to add up our total outcomes. So we want to add 1 plus 4 plus 6 plus 4 plus 1, and we're going to get 16 total outcomes. Okay, so that's going to be the that's going to be the denominator of our fractions. So for the outcome of flipping 4 coins and not getting a single head is 1 out of 16. For flipping 4 coins and getting 1 head, we get 4 out of 16, 6 out of 16, 4 out of 16, and then 1 out of 16. Okay, so the table, the hardest part about the table is getting it set up and determining what X is. Okay, once you figure that out, you use your calculator to figure the outcomes, add up the total amount of outcomes you have to set up your probability of each of those events happening. Okay, so going down to B says use the probability distribution in A to answer each question. So what is the most likely outcome of tossing 4 coins? So once again, what's the most likely outcome? You look which one has the most outcomes. In this case, it's 6. So the most likely outcome for this one would just be 2 heads. Okay, what is the probability that at least 2 heads are tossed? So it's the same thing. So we wanted the probability of when the X is greater than or equal to 2, because it has to be at least 2. So that means it can be 2, 3, or 4. And then we take our probabilities that we've already made, 6 over 16 plus 4 over 16 plus 1 over 16. We add all those together and we get 11 over 16, which is about a 68% chance that you're going to flip 4 coins and you're going to get an outcome with at least 2 heads. Okay, so I hope this helps. Trying to keep it brief, not overwhelm you with information. If you have questions, please feel free to email me, and I'll help you out as much as I can. Like always, I suggest that you work a few of these problems from the book, just so you'll kind of get a hang of it. This is something that you'll see on ACT, stuff of that nature. But being able to look at this probability distribution as a table and as a histogram, and being able to use that data to answer questions like we've answered in this video is really the main point of this lesson. So hope everyone's doing all right. Miss y'all, and